Welcome to this explainer. Today, we're putting on our data detective hats to solve a very specific athletic mystery. How exactly do we maximize sit and reach flexibility using statistics? We're going to use a powerful tool called the Two-Way Repeated Measures ANOVA, and we'll apply it right inside the JASP software to crack the case. Let's get into it.
Here's our procedural roadmap for today. We'll quickly look at what a two-way RM ANOVA actually is, check our key assumptions, run the test in JASP, decode those output tables, dig into simple main effects, and finally report our results. We're leaving absolutely no analytical stone unturned here.
What is two-way RM ANOVA? Before we start crunching the numbers, we need to thoroughly understand this statistical tool and identify the specific variables or suspects in our case study.
So what are we actually dealing with here? With this kind of ANOVA, we have an experiment with two factors, where the exact same subjects receive more than one condition. The crucial thing is knowing the difference between a main effect and an interaction. Think of a main effect as a factor going rogue, acting entirely on its own, like just looking at stretching and ignoring everything else. But an interaction, that's where things get spicy. It's when two factors team up to influence our outcome, like stretching being heavily influenced by whether or not you actually did a warm-up beforehand.
Every good investigation starts with the presumption of innocence, right? Well, in statistics, those are our null hypotheses, and we've got 3 of them here that we're trying to bust. The first 2 basically state that the scores are exactly the same across each level of a single factor, completely assuming the other factor doesn't even exist. The third one claims that there is absolutely zero interaction between the 2 factors, that they operate in total isolation.
Section 2. Checking key assumptions. Time to check our blind spots before feeding anything into the software.
We can't just throw data at the wall and see what sticks. We have rules of engagement. For this test to actually mean anything, our data has to fit specific parameters. We need continuous and roughly normally distributed variables, independent variables with at least 2 related categorical groups, equal sphericity, and please, absolutely no significant outliers. If your data ignores these rules, your whole investigation completely falls apart. But wait, here is a massive statistical loophole that I absolutely love. Sphericity usually requires at least 3 levels to even be tested, but our specific experiment, we only have 2 levels for our stretch factor and 2 for our warm-up factor. Because of this 2x2 design, we literally get to skip the sphericity check entirely. How great is that? Moving right along to Section 3, running the test in JASP. Let's take our raw CSV file into the lab and see how this all comes together. Getting this going in the software is a super logical 4-step process. First, we define our factors and their levels. Second, we assign our data columns to those repeated measure cells. Third, we make sure to tick the box for the omega squared effect size. And finally, we set up our descriptives plot so we can actually eyeball what the data is up to. Setting up that first step in the interface is a total breeze. We define factor 1 as stretching, with stretch and no stretch levels. Then factor 2 is warm-up, with warm-up and no warm-up levels. From there, it's just seamlessly dragging and dropping our specific data columns right into their matching cells. Now, we definitely want a visual lineup of our suspects in action. In the Descriptives Plots menu, we put the stretching factor on the horizontal axis and split the warm-up factor into separate lines. Throwing in some error bars gives us an instant, highly reliable read on how our data is behaving.
Section 4. Decoding output tables. The crunching is done, the suspense is over. Let's carefully interrogate these outputs and find our clues.
Once the results are generated, you're going to see a few different tables. You can completely ignore the between subjects table for this specific run. Our absolute goldmine is the within subjects effects table. This is exactly where we find our sum of squares, our F statistics, our p-values, and those crucial omega squared effect sizes.
And boom! Look at this massive clue. The main effect for stretching, the main effect for warm-up, and most importantly, the interaction between the 2 all hit a significance level of p less than 0.001. So we can confidently throw those null hypotheses right out the window. Our factors are highly significant, and they definitely interact. You know what they say? A picture is worth 1,000 data points. When we visualize the data, notice how the lines representing the warm-up conditions are totally non-parallel? The fact that they're crossing paths is textbook visual proof, demonstrating the strong presence of an interaction effect.
So, let's translate that visual into plain English. The data definitively proves that warming up dramatically changes how effective stretching is. These two variables aren't just acting alone. They're actively having a conversation with each other that directly impacts how far someone can sit and reach.
Section 5. Digging into simple main effects. Finding a significant interaction means our case isn't fully closed just yet. We need to dig a little deeper to understand the real nuances here. By diving into the simple main effects options, we set warm-up as our simple effect factor and stretching as our moderator. What this does is run pairwise comparisons. It essentially isolates the behaviors so we can pinpoint exactly how warming up performs across the different stretching conditions.
Finally, to make absolutely sure our conclusions are bulletproof, we run post-hoc tests. We toss our factors and the interaction into the analysis, tick the effect size box, and critically, we apply the home correction. This adjusts our p-values for multiple comparisons, keeping our math rock solid.
And finally, Section 6, reporting your final results. We've cracked the case. We have the evidence, but the detective's job isn't done until the paperwork is filed. We need to present this clearly to the world.
When formatting our findings into a pristine APA-style table, the F statistics and significance levels are crystal clear. But check out that omega squared column. Effect sizes of 0.647 for stretch and 0.404 for warm-up are incredibly large. It proves our findings aren't just a statistical fluke. They have serious, practical meaning.
So what's the grand takeaway from our data deep dive? The simple main effects proved without a doubt that if you want to maximize your ability to touch your toes, you can't just pick one or the other. Your sit and reach performance only truly peaks when you perform both a warm-up and a stretch together.
Now that you've totally mastered the logic and execution of the two-way repeated measures ANOVA, I want to leave you with this. What complex interaction in your own field of study is just waiting to be uncovered? Get out there, look at your data, frame your factors, and let the software reveal those hidden relationships. Happy analyzing!